So we're going to look at logarithms today, and in a word, a log is an exponent. So when you see log, think exponent, because that's what a log is. So when they ask you to write this equation in logarithmic form, you need to put these three numbers into the form log base something of something equals something. So it's actually pretty easy to figure out where the numbers 7, 29, 3, and 6 belong. It's log base something. For starters, I'm going to draw a box for the locations of the three numbers. And it starts with the base. Now, fortunately, the base of the exponential expression is the same thing as the base of the logarithmic expression. So, I mean, clearly the exponent is 6. So, actually, let's just fill that one in first. Log is exponent. When I say go, I'd like you to say out loud and in unison, a log is an exponent. Ready? Go. Yeah, that's the basic idea. So the exponent goes on the other side of the equal sign. The base of the exponential expression is 3, so that goes in the base location. And by process of elimination, the only other place where we can put the 729 is in the input slot. So we would say the log base 3 of 729 is 6. That's a mouthful, but let's say it together. When I say go, I want you to say the log base 3 of 729 is 6. Ready? Go. The log base 3. Let's say, let's try this. I'd like you to commit, say this out loud and in unison. Let them hear you on the other side of the cinder block wall. Let's give it a go. When I say go, I'd like you to say out loud and in unison, the log base 3 of 729 is 6. Ready? Go.
The log base 3 is 729 equals 6.
That's pretty good. Now, let's go to part B. Let's try it again. Write this exponential statement as a log statement. Log base something of something is something. Go ahead and try to position those three numbers into the right location. You may as well start with the exponent because a log is an exponent. When you're done, tell me what you think the correct answer should be. Owen, what do you have?
Log 2, that 32 equals 5.
Now, that's close. I'd like you to say the log base 2 of 32 is 5. Try it.
The log base 2 of 32 equals 5.
Yeah, 32 is the input to the log function, 5 is the output. And the output of a log function is always an exponent. By the way, the domain of log functions is positive numbers only. So if anyone asks you to find the log base 2 of -10, then politely decline, because log base 2 of -10 is undefined. The input to a log function must be a positive real number. All right. Any questions on this one? Try parts C and D on your own. Convert these exponential expressions to log expressions. Jay, what did you get for part C?
I got the log based on 7 is times 49 equals 2.
That's actually not times 49. There's no multiplication there. You have to say, see, of is like f of x notation where whatever comes after the word of is the input to the function. So say the log base 7 of 49 is 2. Try it.
The log based on 7 of 49 equals 2.
And the of is very significant conceptually. And then how about letter D? Mia, do you have that one?
The log base 0.
Well, tell me first of all, what is the exponent in this expression? Of all these numbers, 10, 0, and 1, which one is in the exponent position? Yeah, 0. So you know that the 0 has to go over here. I would place that one first when you're doing the problem. What is the base of the exponent? Well, the base of the exponent is just whatever number is under the exponent. So that's going to be the same as the base of the log expression. Those two are the same. So place the exponent first, then the base, and then the only number that's left over becomes the input to the function. So try pronouncing this. Try it.
Log base 10 of 1 equals 0.
Yeah, this means that the log base 10 of 1 is 0. A log is an exponent. How many of you find it helpful to place the exponent first over here on the other side of the equal sign? Because a log is an exponent. How many of you are doing it that way? That's interesting. Well, I think you'll be more successful if you do it that way. Like, for example, what number would you place first on this one?
3.
Thomas?
3.
Yeah, put that first. What's the base in this case? Let's go to Daniel for this one. Daniel, what's the base of this equation?
1/2. 1/8.
No, the base is always right next to the exponent.
1/2.
So this is the base, that's the exponent. The base and the exponent are always right next to each other. So the only other number that we could possibly put in there is 1/8. So we've got log base 1/2 of 1/8 is 3. Now, I'd like you to draw 2 arrows. Draw an arrow from the 1/2 to the 3, and then from the 3 to the 1/8. This configuration of arrows can always help you check your answer. Because if you did it right, then you should be able to say this: 1/2 to the 3rd power is 1/8. Or up here, draw the arrows for letter C. Log base 7 of 49 equals 2 by drawing an arrow from 7 to 2, which means 7 to the 2nd power is 49. Draw the arrows up on letter A. Draw both arrows, always starting with the base. After you draw the arrows, you can say 3 to the 6th power is 729. That's a way to check to make sure that your log form matches your exponential form. Do you have any questions on example 1? All right, let's turn the page. Example 2. Now we're going the other way around. It says evaluate each logarithm. Well, to do this, draw the 2 arrows. The first arrow always goes from the base to the exponent. So that means 3 to the x power. The second arrow always comes in like this. So now you can see that it means 3 to the exponent of x is 27. Now you just have to ask yourself, what exponent on 3 would give you a 27? Raise your hand if you think you know the exponent that placed on 3 would give you a 27. Just go through your powers of 3 there. Yeah, go ahead, Thomas. Yeah, it's the 3rd. So we can call this the arrow thing, where you draw these 2 arrows, starting with the base, 3 to the x equals 27. But also, class, if you're doing this in your head, in your mind, all you have to do is go from eyes up here, look up here, some of you aren't looking, eyes up here. Just ask yourself, how do I get from 3 to 27 with the next one? 3 to what power is 27? That's all you're doing when you're evaluating a log expression. What exponent, since a log is an exponent, what exponent do you have to put on 3 to get 27? So, oh, by the way, class, I mean, come on. What exponent do you have to put on 9 to get 81? 2. So you know that when you do the arrow thing, I mean, some of these you can just do in your head, you know the answers too. But draw the arrows, 9 to the x. 9 to the x is 81. So you can tell that x is equal to 2. But if there is no x, just put 1 in. I mean, when they ask for the log base 2 of 16, you might be like, I don't know. Well, then say I don't know by writing equals x. That's your way to say I don't know. Say equals x. So, is there a volunteer to come up and draw the 2 arrows that we do on this problem? All right, Gerald, come on up. So kind of you to come up and take the stylus. Here's Gerald drawing the first arrow. So goes from 2 to x. Second arrow goes from x to 16. Fantastic. Appreciate that. So because Gerald wrote this first arrow, I know to write 2 to the x power. A log is an exponent. And so just brainstorm here. What exponent on 2 would give you a 16? What do you think? on that one. Lauren? What exponent would you place on the number 2 to get the number 16? 4 would do it. So the answer is x equals 4. Now, letter D, a little more complicated because it shouldn't equal 0, it should be equals x. So when you do the arrow thing here, we get 25 to what exponent would give you a 5? Write down what you think the exponent is. A log is an exponent. Comes out to 1/2. Comes out to 1/2. By the way, one more thing before you go. When you don't see a base, it means log base 10. So log base 10 of 10 is 1. This is 3, 1, and 5. So the answers to those last 4 are 1, 3, 1, and 5. Assignment 8.3a is due tomorrow. You are dismissed.